All right. So my portion of our session today, I'm going to be talking about a couple of the user-based tunneling enhancements that we've added in 10.8, as well as we've turned on device fingerprinting on the switch side. I'll go over some of the caveats with that for this initial release of that. So let's go ahead and get started. So first, let's go over the UBT enhancements. So there's two enhancements that we're introducing. One is this idea of role-based auto VLAN creation. So specifically, this is created for user-based tunneling, especially for those using the VLAN extend method, where you need to have the VLAN exist on both the switch and the gateway. By default, we use the reserve VLAN in CX, so everything goes over reserve VLAN, so you don't need to have that in the user role. But if you're using the VLAN extend method, you must have the VLAN exist on the switch. So if you have a lot of VLANs that are going to be doing user-based tunneling using the VLAN extend method, you have to pre-provision those across all the switches throughout the network. So to make it easier, we've automated this in the background. So this happens by turning on a command, and then in the user role, when the user role is parsed to the switch and it sees the VLAN existing there, it will automatically, the switch will automatically create the VLANs for those users. So this can also be used for downloadable roles that are just doing local switching. So if you have devices that are in VLAN 100, you don't need to put VLAN 100 on the switch. All you have to do is have that in the user role, and the switch will automatically create that VLAN. So this simplifies and eliminates the need to manually create all those VLANs across all the switches. This is supported on the 62, 63, and 6400 platforms. The other thing we added in, we've had client IP tracker for a while now, but now we've turned it on for user-based tunneling clients. So client IP tracker, for those who are unaware, tracks the IP addresses of client traffic connected to the switch through the tunnels. And so if the IP address of the client happens to change, that change will be noted in the client IP tracker table so that it can show the changes and track the IP addresses of those devices. So that helps for operators to have client visibility for those tunneled clients, and it makes it easier to notate and track any changes that could happen in the client IP table. And you can also send out an ARP probe at a certain interval. So if there's no client traffic present in the tunnel or on the switch, you can send out an ARP probe to figure out where those clients are to what the IP address is to the MAC address of the client that you're interested in. So you can enable that on the switch, the VLAN, or the port level, and that's also supported on the 6200, 6300, and 6400 platforms. So let's first take a look at role-based auto VLAN. So the scale is based on maximum clients and VLANs available. So the max clients on 64 and 6300 is 256, and on the 6200 is 32 per port. Max VLANs is 4,000, 6200 is 2,000. So some of the caveats with that, it's mutually exclusive with VSX, MBRP, and RPVST. Must be disabled to enable auto VLANs, those features. There's no current SNMP support, and it's not supported, of course, with the reserve VLAN mode of user-based tunneling or local VLAN mode. So how this works, there's a new command to allow authentication-based VLAN creation automatically, and it's this port access auto VLAN command. So once you enable that, the switch will then be waiting for VLANs in the user roles, and once it parses through the user role context, it will automatically create the VLANs in the background. So then the VLAN list, you'll see that the type will be a port access VLAN, which indicates that that was triggered by a role and automatically created. So you can just configure the VLAN in the downloadable role, or local role as well. This isn't just for downloadable roles. You can do local roles as well, or VSA. So any kind of port access client assignment or authentication and radius assignment coming back from the radius server, you can trigger the automatic VLAN creation. For troubleshooting, first thing you want to do is make sure that command's enabled. If you do a debug port access, that will show any kind of output dependent on the auto VLAN command. So here, when the VLAN's created, you'll see something like this, event handler VLAN 200 for event secure client add. So if you're looking for that message, secure client add, which means that the VLAN was automatically created, and then in the background, the debugger output shows that it's auto active and it's been automatically created. You want to make sure that that's returned as okay. So then the final authentication success message indicates that the client was successfully placed into the automatically created VLAN. So now next, let's talk about the client IP tracker for user-based tunneling. So the scale for this is limited to the max number of tunneled clients, which for 6400, 6300, 6200, and 4100i is 1,000 per switch or stack. Some of the key considerations for this: it'll work on an MC lag. It can be configured on lag interfaces. The client, if you're doing it on a lag, the client MAC address will appear as learned on a specific physical lag port, and it works the same as it would with an access port. So it's not supported on a VSX interswitch link, and it won't learn clients from a VSX peer, only local clients to the switch. It's not supported on routed only ports, and it's not supported on SVI ports, so only those that are L2 on a VLAN. So the configuration, it can be configured globally at an interface level or a VLAN level, and you'll use the client track IP command for that, and then you can enable it for the port and change the update interval if you so choose. So the default interval is 1800 seconds. It's recommended setting to leave it default, but if you need to maybe have an event of congestion or IPs changing, you can lower it for troubleshooting. Just use caution that it'll generate multiple ARP probes and additional traffic in the network. So the show client IP lists the client IP and MAC addresses that are being tracked. So when an IP is changed, the list will update, which could result in multiple entries for the same MAC address. If the IP address changes, as you see here in the table, you'll see the same MAC address but different IPs. So it'll note for a period of time, it'll save cache the old entry until the time's out, and it'll have the new entry in there as well. So at the port level, the client IP tracker is set to auto, which is the default mode and should be best practice. The feature can also be enabled and disabled, as well as set the client limit for the number of clients that'll be tracked at the interface. And then as I mentioned, the update interval can also be adjusted. So when the interval, if you have the update interval set and the timer expires, the switch will send out an ARP or an ND probe to probe the clients for any address changes. So this is what it would look like in a packet capture, and the client will respond back with the new address, which will then be updated in the client IP table. So here my switch is sending out the ARP broadcast, and then the client here is responding to it with its new IP address as part of the packet capture. So kind of the troubleshooting flow, you want to check that the IP tracker is enabled globally, check that the feature is enabled on a desired VLAN or port, make sure it's enabled there. Verify that clients have some traffic on them so the switch can detect the IP address from the traffic, and then ensure that the probe update method is enabled if no client traffic is received, so that if the IP address does change, it can monitor that as part of the client IP table. So let's take a look at a demo for client IP tracker with UBT clients. So this is an add-on to client IP tracker, which has been around since 10.5. So in 10.8, we've enabled it for user-based tunneled clients. So the one important thing to note is that it needs to be enabled globally as well as on the VLAN for user-based tunneled clients. So there's two modes that we use, the reserve VLAN or local VLAN method, and then the VLAN extend method. So whatever VLAN we're using for those configurations, we need to make sure that we have client track IP enabled on those VLANs. So for the demo purposes, we are using the VLAN extend method. So we can see that with this UBT mode command VLAN extend. And we have client track IP enabled globally. And then on VLAN 200, which is the user VLAN we're using, we have client track IP enabled there as well. So then if we go to our switch, we can do a show UBT state. So we can see that we have a client currently being tunneled there. If we do a show UBT user all, the tunnel's been activated, same MAC address that we see up here in the show UBT state command, and we're in the gateway role of client. So if we do a show port access clients, we can also see that the client has been authenticated and is working. If we do a show client IP, this lists the client IP table, so we can see the IP address that is currently being tracked on that client. So then if we go to our client, we can change the IP address from here and see the change in the tracker table. So right now it's getting a DHCP address, so we'll give it a static IP, get a 75, and then we'll add in the mask and the gateway and save it. And then we should be able to see, yep, that it's changed the IP address. So now if we go back to our switch, it should show up soon in the list here. So now here, after just a couple of seconds there, we can see that the switch now sees both IP addresses, that it's tracking the old address and the new address. So after a while, it'll send out a probe, and if it doesn't get a response at the old address, it'll delete the old stale ARP entry and then save the new entry. So that's how Client IP Tracker works. It just tracks changes of IPs of clients, so it makes it easier for an operator to be able to manage all the client IP addresses downstream from an easier way to troubleshoot, and it provides a little more visibility into IP addresses of clients, especially with user-based tunneling. And then you can see after I've talked for a few more seconds, the old entry has disappeared, so now we just have the new entry. So that's how Client IP Tracker over user-based tunneling works. Thank you very much. Finally, the last feature I wanted to talk about is device fingerprinting. So device fingerprinting is achieved by configuring a switch to act as a collector, and that collects traffic patterns and then can send the specific attributes that it can detect from the client to an analyzer. And then the analyzer can then process that information and fingerprint the device. So our CX switches can now act as device fingerprinting collectors, and that'll collect specific protocol data sent by clients, and then that would send it to an analyzer to fingerprint the device. So currently in CX as a collector, we have 4 protocols that we're supporting with this initial release of device fingerprinting. It's DHCP, HTTP, LDP, and CDP. And then the analyzer, of course, is an entity that processes the information collected from the collector and then fingerprints those devices. So an example of that can be Central, or ClearPass Device Insight, or ClearPass itself. So previously, we had device fingerprinting on the AOS switch line. So one of the main use cases for device fingerprinting are so that operators have the best visibility into the types of devices that are being plugged into the switches at the access layer. And by being able to obtain as much information as possible from a client, we can create more granular security policies based on manufacturer, device type, MAC address, vendor, operating system, so we can get these more advanced fingerprints and be able to enhance security policies, especially when you're dealing with headless devices that don't have built-in security, that you can create more granular security policy to only enforce that specific types of devices can access the network. So this is the first phase of device fingerprinting in CX. There's really not a whole lot of analyzer support right now as we're releasing 10.8. All of the fingerprinting information that is gleaned from the switch is saved into the database, the OVDSB or OVSDB of the switch itself. So the first phase really for analyzing and sending extra data to an analyzer is coming with Central support in 254, where it will be able to get the host name from a device and send that to the client info of Central. CPDI support is coming in the future. There's no committed date yet, and ClearPass support is coming into the future. No committed date yet. So this is device fingerprinting supported on the 6200, 6300, and 6400 platforms. So the scale for the 6300 and 6200 is 2,000 clients that can be device fingerprinted. For the 6400, it's 4,000 clients. Maximum number of device fingerprinting profiles is 32 for all the supported platforms. So Important to note, the only analyzer that's currently going to be supported is Central 254 in a couple of months, which can receive the hostname attribute from the switch fingerprinting attributes. So as we build out the solution more, we'll of course provide more information for you in future under the hoods and TOIs. So how this works is first you need to create the device fingerprinting profile, and then you need to select the protocols that you want to use. So we have CDP, DHCP, HTTP, and LDP currently supported. And then you can apply that profile to the interface that you're going to use after you selected your protocols that you want to fingerprint using, and then you apply the profile to the interface. Supported LDP parameters currently are the chassis ID, port ID, time to live, port description, system name, system description, system capabilities, and management address. For CDP, it's chassis ID, port ID, address, capabilities, version, platform, native VLAN, and duplex. For DHCP parameters, so option 12 is the host name. That's the one we're currently putting in for Central 254. And so that'll provide host name information from the client. We can also do option 55, which is parameter requested list, and then option 60, which is the vendor class identifier. So the combination of the option sequence in 55 or 60 is used to infer the OS and device type of the remote client. And the supported HTTP parameters are HTTP user agent. So this might be useful. There's not a whole lot of HTTP applications, but for a captive portal, something like that, if you need to detect their captive portal, you can use HTTP for that. That's really the main use case that's been designed around for device fingerprinting for HTTP. So to show the device fingerprints, you would do a show client device fingerprint, and that would show the clients that are connected to, that are being fingerprinted and detected by the switch for fingerprints. And then you can also see, for example, the host name that's being sent back from the switch for device fingerprinting. You can actually see that in a packet capture. For instance, my laptop here was doing DHCP fingerprinting, and you could actually see that be returned from option 12 in the DHCP packet capture. So in Central 254, if you show the client's details in that, you would see the host name pop up as part of that. And so this is what it would look like. Whoops. And I'll show that in just a minute. For troubleshooting, we've introduced the debug device fingerprint command. So if you run the debugger, you can actually see the device fingerprints that are coming in. So if you're not seeing any output, you'll want to check your protocols, make sure it's enabled on both sides. Make sure DHCP server is working correctly if you're using DHCP, or LDPs enabled on both ends or on the client that's being, especially on the client that's being fingerprinted via LDP. But the debugger would show you the actual fingerprints that it's detecting from the client itself. You want to ensure that the profile is created and enabled. Ensure that device fingerprinting is enabled on the port as well. So you enable it globally as well as on the port. And then you want to ensure that the appropriate protocol is being transmitted and enabled on the fingerprinted device. You know, for example, having LDP turned on, DHCP enabled, CDP enabled, etc. So let's take a look at a couple demos here. So first, let's go over the user-based tunneling, the automatic VLAN assignment. So here in Central, here's my switch that's doing user-based tunneling. The new command here is port access auto VLAN. So we can see that as part of the configuration. That's the new command we have. For this demo, I'm going to use VLAN 200. I do not have that defined currently on my switch according to the config. And then what I'm going to do in the background here is I'm going to disable and enable my clients. I can plug into the right port. And then I'll bring up my console window here. And if I do a show UBT user all, we can see I have a tunnel up, show port access clients. My role's been downloaded successfully. If I do a show port access role, I can see here's my role that's been downloaded. My role name's client. I'm going over gateway zone, zone 1, and then my VLAN is 200. So then if I do a show VLAN, here's my VLAN 200, and it's come up via port access. So that's what you're looking for to make sure that your VLANs are automatically created in the background using a user role or a tunnel client using the VLAN extend method. Just to verify as well, I'm using VLAN extend for my user-based tunneling. If I go take a look at the role here, we can go to clear pass. So I just have the role defined here with my tunneling command, and then the VLAN that I want to use on my switch that I want automatically to be created. So you just specify the VLAN in the role. It's pretty simple to do. Enable that global command, the VLAN port access VLAN command, and then the VLAN will automatically be created in the background. So that's the automatic VLAN with user-based tunneling. Next, let's take a look at device fingerprinting. So using that same client, go back here, using that same client connected to port 112, I have device fingerprinting already applied to that client. So then if I do a show client device fingerprinting, we can see that it's detected my client and over DHCP using the DHCP, and it's received the host name, and then any parameter requested list, and then the operating system shows as Microsoft 5.0, but that's Windows 10. And I also have a switch connected to this, so it's also fingerprinting that switch via LDP, showing up as a Aruba 2930F 12-port switch. So we're validating here that device fingerprinting is working on the switch and can send the fingerprints out. So that if I go to Central 254 and I go look at my clients, after it loads up here, I can then scroll down and I can see the host name here. I can actually, it makes it easy to find my client by the host name. I can actually click on the client and see that I've got the host name from device fingerprinting in Central 254. So that's a little demo on how device fingerprinting works. It's limited now, but of course we'll beef it up in the future. Future releases of Central and ClearPass and Device Insight. We'll be adding more functionality into that. But we have the infrastructure set in place with the switch, which is what we wanted to show you, give you a preview of what's to come with that.